Hello everyone, I am Sanjay. Now my project AI about climate change prediction and action planner. Now we are going to discuss our project agenda. There are different introduction, statement of problem, scope of the project, methodology, output, result, test case, conclusion, future work, reference. These are the agenda of my project. Let we see one by one. In introduction, climate change is one of the most critical global challenges affecting the environment, economy, human, which is not suitable for touch-free and virtual environment. Traditional climate analysis methods rely on historical data and manual interpretation, which may not provide accurate future prediction. This project uses a webcam and a media pipe to capture and track hand movements in real time. Artificial intelligence and machine learning enable the analysis of large climate datasets to identify patterns and trend efficiency. Now move on to the statement of the problem. What are the statements and the challenges we faces? Lack of accurate and timely climate change prediction due to reliable on traditional statistical methods, and the objective to develop an AI-powered climate change prediction system that analyzes historical and real-time climate data to forecast future trends and provides an action planner to suggest mitigation and adaptation technique. Now move on to the scope of the project. AI-powered climate change prediction and action planner. Scope: develop an AI-based system to analyze historical and real-time climate data using machine learning techniques. Implement pre-processing techniques to convert uh, hair written strokes into 28 cross 28 images suitable for CNN input. Implement data pre-processing methods to clean, normalize, and prepare climate data sets for accurate prediction. We want to target audience and government agencies, environmental organization, such that etc. Deliverables. A trained and validated AI model for climate change prediction, a real-time hair writing and recognition application using a standard webcam. Now move on to next slide. Scope of the project: inclusion and exclusion, data pre-processing and feature extraction of climate prediction, and a real-time control for automation of environment system. Under the data, historical climate data sets including temperature, rainfall, humidity, CO2 emission level. These are the data we want to collect it. Under the limitation, prediction accuracy depends on the quality, size, completeness, and of a climate data set. Sudden and unpredictable natural events may affect prediction reliability. And also the model performance may vary across different geographical regions. The methodology: we want to data collecting, pre-processing, AI model development, application development, and integration and testing. Finally, integration and testing. These are the five steps we want to use in AI powered climate change management. Historical and real-time climate data such as temperature, rainfall, etc. Data collected climate data is clean to remove missing values and outliers. Using machine learning and deep learning models too, we want to develop the model development application based on the predicted climate outcomes. And action planner model is developed to suggest material adaptation. Next, the integration: the trained AI model and action planner are integrated into a single system. Next, climate data acquisition includes climate prediction, and action planner process includes pre-processing climate data through cleaning, normalization, feature selection, feeding pre-processed data into AML prediction model, and the acquisition வந்து collecting historical and real-time climate data from reliable meteorological and environment sources. This is the architecture diagram from our project. We want to first get the input under the layer pre-processing, decision action player layer, decision logic, prediction layer, under the story layer. Finally, we get the output. Design use case diagram. Use UML diagram. A use case diagram represents the interaction between different actors and the AI powered climate change prediction and action planner system. It shows the set of use cases enclosed within the system boundary and the communication between user and the system. The use case model defines both the external actors and the internal functionality of the system. This is the design use case diagram of our project. We will get the input from the user and collect climate data, perform data pre-processing, climate prediction, and the action product, decision logic, this recommendation, admin, user, and finally we get the output. This is a design class of diagram. First we want to data pre-processor, next climate model, action planner. clear data, normalize data, select feature, algorithm or recommendation. These are the steps we use in our project. This is the sequence diagram of our project. User to satellite data sources, climate prediction system, action planning system. uh, from where itself we get the input, this will be continue. From the we get the output. Next, uh, this is although the sequence diagram of our project is same to the front page. This sequence diagram uh, is have a user, IoT satellite data source, climate prediction system, action planning system admin, and the pre-processing climate prediction system admin, etc. This tells the we want to pre-process data, send real-time data, predict future climate, and we want to display the output, character, confidence, whatever it is. What are the algorithm used? Machine learning regression algorithm, such that a regression model such as linear regression, random forest regression are used to analyze historical climate data and predict future climate parameters like temperature, rainfall, and CO2 levels. Algorithms such as ARIMA and LSTM, long short-term memory, are used to identify long-term climate trends and make accurate future prediction based on the past data. Classification models are used to categorize climate risk levels, low, medium, mind, and assess environmental impact in future. And these are the machine learning prediction models. Machine learning models are used to predict future climate conditions such as temperature, rainfall patterns, and greenhouse gas emission. And we want to the trained models provides accurate prediction based on learned pattern in climate data. Mhm. Machine learning models improve prediction accuracy without recurring manual rule based programming. Next, hardware and software selection. What are the hardware and the software that are we need for our project? System, laptop. This is the basic thing used for data processing, model training, and system execution. Climate data sources used for collecting historical and real-time climate data, temperature, rainfall, CO2. Python program, machine learning algorithm, TensorFlow, Graphs. These are the libraries. And the scikit-learn, pandas, and numpy, matplotlib we want to use in our project. Implementation. The project is implemented using Python programming language. Climate data is collected from reliable historical and real-time data sources. Under the time series model, LSTM, RMA are the time series model. The trained model predicts climate indicators such as temperature rise, rainfall changes, and CO2 emission. These are the implementation. Important code segment. Input data set. These are the basic codes that we used in our project. Input data set pre-processing, data source loading, model prediction, climate trend analysis, action plan generation, climate prediction model architecture, model training, output display. This is the output. We want to from the beginning itself to the end. We have many process: datasets directory, load datasets, train model.py, and pre-processed data, Postgres database, log file, action plan. What are the action plans we required in the climate change prediction? This is the output of the project. This is the sample output. Climate monitoring system, monitoring system active, log enabled. It's analyzing climate data, prediction initialized, CO2 emission alert critical. This is same as the output. This is the values that are stored in the database. In 2025, date wise, temperature, it stores the value, and which day has more climate change, that stores. This is the test case. Nothing test case is nothing but data sets loading, data pre-processing, model training, climate prediction, and output display. This is the same for e-commerce type of object project. System starts and loads dataset, data pre-processing, model training, climate prediction, action plan generation. This is the result of our project. Accuracy 91%, precision 88%, recall 90%. This is the graph of our project. Conclusion. In this project, experimental results demonstrate that the use of artificial intelligence and machine learning techniques significantly improves the accuracy of climate change prediction. By analyzing historical climate data and identifying complex patterns, the system effectively forecasts future climate conditions and trends. And the future work in the current implementation system focus on predicting climate parameter using historical data and basic machine learning models. In future work, the project can be extended to include real-time climate data integration from IoT sensor and satellite sources for more accurate and dynamic prediction. Further improvement can include the use of advanced deep learning model such as transformer and hybrid AI model to enhance prediction accuracy. This is the website we take the reference from this website, and the book reference Lon Goodfellow, Yeshua Bengio, and Aaron Corvilla, Deep Learning, MIT Press 2016, and the Trevor Hasty Robert Tipshirani and Jerome Friedman, the elements of statistical. Hello everyone, this is the continue of my project explanation. This is my project executing method. Our project AI powered climate change prediction and action planner have different types of files: PyCatchy, configuration file, source file, and the app dot and all the Python files like action.py, data fetch.py, app.py, model.py. In action.py, what are the action we want to do in the climate change prediction and action planner? What the action we want to need? If a climate change means what are the action we want to need to take? Data fetch. What are the data we want to fetch in the project? And app.py, it is used to run our project. And for our project it have multiple libraries imported, and the sidebar and right emission factor. This model, what are the model you want to do? By using libraries, the forecast results model, linear regression model, and history PD data frame, forecast PD data frame, me float, and then add time feature and a train and forecast, train test split, etc. In in the, what are the requirements you want to do in? These are the requirements libraries we are imported in our project: pandas, numpy, scikit-learn, meteostat, reco, streamlit, matplotlib. These are the libraries we imported in our project AI about climate change prediction. I mean, and the emission factor JSON and this method. If the AI about climate change prediction, we want to choose the one location. If the example Chennai means, if we give Chennai, it look up the city and give the output like latitude, longitude, and we want to the four types of vector, that is beef, rice kg per serving, LPG, gasoline. Now we run our project and execute it. This is our project AI about climate change prediction and action planner. First of all, A, fetch historical data and computer. If we give Chennai, we want to look up the city. It looks up and give found Chennai, India, latitude and longitude. It automatically entering into the coordinates overall or optical optional override latitude, longitude. Under the emission factor, we want to adjust why decrease or increase, and a beef decrease or increase. We want to adjust all the things. After adjusting, one second. After adjusting, if we mhm. And this taking latitude, longitude, and emission factor. If we give accurate emission factor, it give the output. Otherwise, if we give random, it can't. Your under emission factor, your usage and your estimates: household electricity, weekly car travel, beef meals per week, rice meals per week, and then electricity kilowatt, gasoline vehicle, beef, rice, how many. It will be calculated how much beef executed in a month or a day, and rice, gasoline vehicle. If you run, it fetched the 9,537 daily records. It gives the monthly preview, month end, average, year, month, baseline, anomaly. It gives the record monthly average temperature as a graph from 1990 to 24, and monthly temperature anomaly from 1991 to 22 20 baseline as a graph, and anomaly forecast, history forecast next for next 12 months what it can be. So 1992 to 2020, it can now 2025, it can execute and calculate for till 2028. And the